Hey everybody. I don't know if this is in my webcam. There it is. Hey everybody. Hope we're all having a good day today. I figured you could see my face again. Some of you guys were like, "Oh, it's kind of nice to see your face without a mask." Oh, geez, my hair is. All right. So welcome to my kitchen. Welcome to my dining room. This is the Laverick household. But hopefully we're all having a good day. I will. I'm going to make a video going over section 2.9. Sorry, I'm not with you guys. I'm taking care of kids at home. But I'll be back tomorrow. Don't worry, it's not like a quarantine issue. So I'll be back tomorrow. Well, as of 10 p.m. on October 13th. But the first thing I'm going to do, I am going to show the key for the homework. So if you could get that out, make sure you submit that. I'm going to take my face off the screen because I think that's kind of weird. It was kind of weird having me up there last time. So see ya. All right. So here's the key for the homework. You did not need to do 3, but there's the answer for that one as well. So if you wanted to see it there, you could. But there's 2, 3, and 4. Okay, pause if you need to. All right, so if you have not already done so, please get some guided notes. If the sub has not already given them to you, make sure you go get that. This is section 2.9 guided notes. It's about absolute value functions. Okay. All right, so now when we did our parent functions, we hadn't really talked about this one called the absolute value function. Okay, the absolute value function. So let's kind of go through what the parent function looks like and all the details about it. Whole rundown. Fill in where you need to. But the domain of any absolute value parent or any absolute value function is all real numbers. I can plug in anything I want into there without restriction, right? I could plug in all negatives, all positives, anything I really wanted to. I could plug in anything I want without restriction. So the domain is always all real numbers. Now the range values, now what is the output? Well, I'll think about all the outputs. The outputs is always going to be positive, right? So non-negative real numbers. Notice how it says non-negative numbers. So that's like all saying y value is greater than or equal to 0, right? Because it still could be equal to 0 if I really wanted to. And again, this is just talking about the parent function. If I shift it downward, then obviously it could go down past the or the x-axis, excuse me. But and we've got a special name for the that point down there at the bottom. That's called the vertex of that absolute value. Okay. So, just filling in the table here, yeah, you could pick anything you wanted here. -2, -1, 0, 1, and 2, -10, -5, 0, 5, 10. All it's going to do is just going to make negatives positives, and it's going to keep positives positive, right? And that's what it looks like over here. It's just that simple V shape, right? That's what you should see, the V shape of this graph, okay? Absolute value V shape of this graph. And so what we're going to do today is kind of investigate that and see what we can do and try to manipulate that as much as possible. Okay, so let's go through the transformations. Now these are the translations. Okay, the translations. Now remember, I had a little bit different notation, and that's why I gave you a little bit of room off to the side or down below it. The vertical shift is f of x is going to map to f of x plus k. That's going to shift it up or down. Horizontal, that's going to take f of x and map it to f of x minus h. Now remember, the difference between these two is that this one happens on the outside of f of x, and this one's happening to the input value. I'm changing the input from x into x minus h, okay? So let's see how that works here. We're going to perform the transformation on f of x, and we're going to move it 5 units down, 5 units down, and graph the transform function g of x. Okay, so if I want to move that 5 units down, that's a vertical shift where it's going to make f of x map to f of x minus 5, right? F of x minus 5. So that means that since f of x, this is truly what g of x is going to equal up here, right? G of x is going to equal to f of x, which was the absolute value of x, and then I just tack on a -5, literally just like that. So let's go ahead and graph that. Now I'm going to graph my parent on the same graph as my new. So parent was just 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, so on and so forth up here. But also -1, +1, -2, +2, -3, +3, and so on and so forth up there. Ooh, kind of squiggly there. That was F. So let's find G. Well, if I wanted to, I could just shift all these points 5 units down, right? 5 units down. 1 comma -4, 2 comma -3, right? I'm just subtracting 5 units to all of these. Notice how the slope remains consistent on either side. You know, if I think about the two sides of this V shape, they are parallel to what we had above. Right? So those are really, you know, those lines are consistently evenly spaced up there. Okay, and then so that was G. That was G. All right, so let's shift it left and right. Okay, so shifting it left. Remember, shifting left, that's going to take f of x and map it to f of x plus 1, right? Remember, the left and right, the shift left and right, that's going to be the additive inverse of what you think it would be. So if I'm actually shifting into the left one, going -1 unit, that'd be like x minus a -1 or x plus 1. That's why you see the plus 1 there. So now my new g of x, remember the old f of x was the parent, was just the absolute value of x. So that means, so you notice how the input was just x inside there? So inside, I'm going to take the old input x and make it x plus 1 on the inside now. Okay, so that means it's going to shift it. So here's the old, right? Here's the old. Here's f of x. 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and so on and so forth. Ooh, yikes. I kind of got it out of hand. And then up here. Oh, wow. This is me using my tablet. Sorry, folks. Okay, now shifting it 1 unit to the left, all that does is that shifts that vertex 1 unit to the left. The slope remains consistent on either side. Okay, let's see how good I do there. Okay. Let's see how good I do here. Not so much. Whoa, got really squiggly there. But you get the idea. I'm making that V shape just shifted 1 unit to the left. Okay, this point gets shifted here, this point here, this point here, this point here, and so on. Okay. But there's the equation, right? There's the equation for g of x. All right, so this is on the back of the guided notes now. You know, we see that shifting left and right does something to the inside. Shifting up and down does something to the outside of the absolute value. So what we can do is they are really independent of one another. So if I shift left, right, and shift up, down, it's not going to change one another. So what I'm saying here is that I can actually create what's called the vertex form of an absolute value function. And that's what you see there on your guided notes. I'm going to get this, I'll go away. Okay, so the graph of g of x is equal to x minus h plus k. Notice how I've got both of those things happening at the same time. The absolute value of x minus h and then a plus k sitting on the outside is basically the image of f of x after it's horizontally shifted h units and vertically shifted k units, so that the vertex is at h comma k. Okay, so that means that if I say, you know, the vertex is at 2 comma 3, right? Then I know that this vertex form, that g of x is going to be x minus 2 plus 3. If I know the vertex is at -7 comma -8, I don't know, then we know that this is g of x is equivalent to the absolute value of x minus a -7, so plus 7, and then -8. Now remember what that means. That means the vertex is at 2 comma 3. The vertex is at -7 comma -8. And at that point, we can take it from right to left using that same consistent slope on the right side and the left side. Notice that I haven't changed the slope. I haven't multiplied anything to x yet. The slope has not been changed. But what has been changed is where the vertex is. Okay, so let's take a look here. We're going to translate f of x is equal to the absolute value of x so that the vertex is at -1, -3. Okay, well, that means that g of x is equal to the absolute value of x plus 1 minus 3. Okay, so -1 comma -3 would be right there. And now I go to a consistent slope on either side, a slope of 1 on either side. Here, 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 here. Okay, let's see. You know what I'm going to do? I'm a cheater, pumpkin eater right here. There we go. There we go. Yeah. That's some Bush League stuff right there. There we go. Works out. Nice clean V shape there. All right. Okay. So let's talk about what happens when we change the slope. Well, sorry, reflections too. Taking a look at the reflections, if it's a reflection across the x-axis, I change the y value, so this is going to be negative f of x. And if it's a reflection across the y-axis, I'm going to change the x value, so this would be f of negative x. Notice that this negative would go on the out, since it's on the outside of f of x, it would go on the outside of the absolute value. Since this negative is on the inside of f, I'm changing it so that the negative would go in the inside of the absolute value. Now, do we see something about the reflection across the y-axis? Isn't the parent reflected across? Like, what happens if I reflect it across the y-axis? Isn't it symmetrical? The reason being is, isn't this the same thing as this? Right? Aren't those two things equivalent? So therefore, the reflection is actually the pre-image is the same as the image if I reflect it across the y-axis. Now, if I had shifted it over, now obviously if like there's my V shape, now obviously then it is going to change. Then those two things are not equivalent. Pre-image is not the same as image, but I'm just talking about the parent, the original parent, and then if I reflected the parent across the y-axis, only doing that, then it would look the same. Okay, vertical stretch and compression, that's that a times f of x. So f of x is going to map to a times f of x. That's multiplying it on the outside of the absolute value. And then remember, this is that tricky 1 over b thing. F of x is going to map to, this is horizontal stretch or compression, f of 1 over bx. So it's the reciprocal of the value. And then you're multiplying that on the inside of the absolute value. Okay, take a look here. Stretch the graph f of x is equal to the absolute value of x minus 1 vertically by a factor of 2. Okay, so stretch vertically by a factor of 2. Anything stretched vertically by a factor of 2 would be this. There is my transformation rule. All right, so that means my new g of x is going to be equal to 2 times my entire f of x, the absolute value of x minus 1. Now, I do distribute in, but be careful here. I can't go all the way to the inside of the absolute value, but I can sit right outside it. And then I have a minus 2. Okay, so that means, well, you know, if you can't really tell what's going to happen with the slope, heck, plot a table of values, right? So if I plugged in negative 2, I plug in negative 2 turns positive 2 times 2 is 4, minus 2 is 2. If I plug in negative 1, this turns positive 1 times 2 minus 2 is 0. If I plug in 0, I get 0 minus 2 is negative 2. If I plug in 1, I get 1 times 2 is 2, minus 2 is 0. If I plug in 2, I get 2 times 2 is 4, minus 2 is 2. So we have negative 2, comma 2. I have negative 1, comma 0. I've got 0, comma negative 2. And then it's reflected, 1, comma 0, 2, comma 2. If you're plotting points and you haven't seen the V shape yet, then you might want to keep plotting points. Okay, I think it would be advisable to just keep going until you see the full V shape. There, you know, no transformation will take it away from what the actual function looks like. So if you don't see a V for absolute value, then you keep plugging in values to see what's going on. But notice here what happened. The slope is actually turning into a 2. Look, rise 2 over 1, rise 2 over 1, rise 2 over 1, and so on and so forth. But it's just making the slope a negative slope on the left side of the vertex. Okay? All right, so let's take a look at one more. Stretch the graph horizontally by a factor of 2. Okay, so in this case, stretch horizontal looks like this. F of x is going to map to f of 1/2 x. Remember, it's the reciprocal of that value. So my g of x is going to take this old function, and I'm going to, in place of x, I'm going to write 1/2 x. The 4 stays there, people. The 4 stays there. All I'm doing is taking away x, and in its place, writing 1/2 x minus 3. The only reason I'm putting in parentheses is to show multiplication. So I've got the absolute value of 2x minus 3. So let's take a look here and see what happens. Make sure that it stretches horizontally. Okay, let's pick a quick table of values here. Let's pick again, -2, -1, 0, 1, 2. Plugging in -2, that would be -4, turn +4, -3 is 1. Plugging in -2 or -1, I get -2 turns +2, -3 is -1. 0 turns to -3. 1 turns to -1, and 2 is +1. -2, -1, -1, -1, 0, -3, 1, -1, excuse me, and then 2, 1. Okay, so I have my V shape again, extending it throughout. Don't you guys wish you could have a tool like that? I guess it's just called a ruler, right? You could just use a ruler. And there we have it. There's the absolute value function. Notice again that the slope is 2, right? Anytime you multiply the absolute value by anything, that's actually what your slope is going to be. With exception to if there's already being added or subtracted on the inside and then you multiply it on the outside, it just changed things just a little bit. But usually the number that you're multiplying by here, that's your slope, usually. I don't want to say always. It's always good to run a table of values. Know that you can plug this into your calculator as well. Your calculators do have an absolute value function. So if I wanted to graph this, let's get everything out of here. Let's get that cleared out, clear. If I wanted to graph this, so here's my old, it's in math, number, abs. Absolute value for x, close my parentheses, -3. And then we have the absolute value, math, number, abs. Absolute value of 2x, close parentheses, -3. I'm going to zoom 6 to get it back to my standard 10 by 10 window. There's my old. There's my new. Right? There's my old and there's my new. Did it look like it horizontally stretched? I would say so. All right. Okay, well, that's all I got for today. It's quick notes day. Make sure you do the homework. And yeah, hope we're all having a good day. I'll see you all tomorrow.